Welcome to Chapter 4, Debugging and Error Handling. When we complete this chapter, we'll be able to recognize error types, trace errors with dialog boxes in the console, trace errors with debugging tools, and write code to respond to exceptions and errors. Programming languages have their own rules. The ways in which we have to combine keywords, operators, punctuation, and so on. Those rules are known collectively as syntax. Programs also have their own logic, the order in which various parts of the program run, or execute. A bug refers to any program error. Bugs cause the program to function incorrectly due to incorrect syntax or flaws in logic. Debugging is the process of tracing and resolving errors in a program. Understanding syntax errors. Syntax errors occur when an interpreter fails to recognize the code. Remember, JavaScript is an interpreted language, meaning that instead of the file being compiled all at once, it's instead read line by the browser. Causes of syntax errors include incorrect use of JavaScript code, for example forgetting a semicolon or a closing curly brace, or references to non-existent objects, methods, or variables, for example trying to use a variable that you haven't yet declared. Runtime errors occur when the interpreter encounters a problem while the program's executing. These can be, but aren't necessarily, JavaScript language errors. A runtime error could also be something like dividing by 0. Runtime errors occur when the interpreter encounters code it cannot execute. Another type of error, a logic error, refers to a flaw in the program's design. Logic errors result in anomalous outcomes, meaning that the program doesn't run as anticipated. We may have to rearrange the execution of program statements in the correct order in order to produce the desired results. Here's an example of a logic error. In this logic error, we multiply instead of dividing. In the first line of our example code, we set the variable division result equal to the product of 10 and 2. We then write to the document, starting in the second line of code, 10 divided by 2 is equal to, and then display the division result, which is 20. That, however, is a logic error. We would have instead needed to divide those two numbers to produce the correct answer of 5. Here's another example of a logic error. We start with the for loop, but instead of incrementing our counter variable count, we just leave it the same. That results in an infinite loop because count starts at 10, and the condition count is greater than or equal to 0 is always true when count remains 10. That results in this infinite loop. To correct this logic error, let's go ahead and decrement that counter variable count by 1 each time the loop iterates. Interpreting error messages is the first line of defense in locating bugs. The error messages are displayed in the browser console, where you'll see a description of the line number where the error occurred, and the description of the error. For runtime errors, the error messages are generated by a web browser, and these can be caused by syntax errors, but not by logic errors, because our web browsers aren't smart enough to know when we've programmed accidentally a logic error. Here's an example. In the function at the bottom of the slide, we're missing a closing curly brace. If we look at the console window in our browser, we'll see a text of the error message as follows, missing closing curly brace after function body, and we'll even see what line number that occurred in, line 22. The error message displays the error's general location in a program, but isn't always an exact indicator of where the error is. Also, browsers do not strictly enforce JavaScript syntax. thereby making it possible to have a JavaScript file that contains syntax errors. Syntax errors can be difficult to pinpoint, but a few common techniques can be helpful in tracking down bugs. The first is to trace errors with the window.alert method. Tracing means to examine statements in an executing program. We can use the window.alert method to trace JavaScript code. We simply place the window.alert method at different points within the program, and in the method, display the variable or array contents or value returned from a function. The window.alert method will allow us to check the values of different variables as the code executes. Here's an example. In our function calculatePay, we suspect that there's an error. We're receiving anomalous results for our gross pay variable, and so in line 4 of our function calculatePay, we include a window.alert message to display the contents of gross pay. We could then verify that the results of gross pay are what we'd expect, and if they're not, we've located our bug. Or at the very least, one of our bugs. There are, however, some drawbacks to using window.alert when debugging our programs. For example, we would have to close each dialog box every time it appears for the code to continue executing. Also, we can only use window.alert selectively at key points, so we'd have to have some sense of where the error is occurring before we decide where to insert the window.alert method. Another helpful tool in locating bugs is to comment out problematic lines. That helps isolate the statement that may be causing the error. When an error message is first received, we can start by commenting out only the statement specified by the line number in the error message. If we still have an error, we can continue commenting out lines until the error is eliminated. Then we'll know that the error must have occurred in one of those lines that we had commented out. It's also possible to combine some of the previously mentioned debugging techniques. This can aid in our search for errors. For example, we can use comments combined with an alert box to trace any errors in the calculatePay function. Here's what that example would look like. We use the window.alert method to display gross pay, and we comment out a whole block of code where we suspect an error may be occurring. A dependency is a relationship in which one statement depends on another statement executing successfully. Dependencies can make debugging even more challenging. It's important to retest the program after fixing a bug to ensure that other parts of the program aren't affected by change. It's best to trace some errors with the debugging tools that are available in current versions of all our modern browsers, Internet Explorer, Chrome, and Firefox. These debugging tools are accessible through the same panel that opens when you use the console. Debugging tools help trace each successive line of code and provide a more efficient method of finding and resolving logic errors. The debugger window is usually a separate pane attached to the bottom of our browser window, but it's also possible to detach the debugger pane in its separate window. Here's what the debugger tool looks like in Internet Explorer, Firefox, and Chrome. When using the debugger window, it's often useful to set breakpoints. Breakpoints cause the program to execute in break mode, meaning the temporary suspension of program execution. This mode is used to monitor values and trace the execution of the program. A breakpoint is a specific statement where the execution enters a break mode. In other words, the program pauses at a breakpoint. When the program is paused at a breakpoint, we can use our debugging tools to trace program execution. We'll see examples of setting breakpoints in the tutorial. To set a breakpoint, click the line number of the statement where the execution should stop. Then click the Resume button in Firefox or Chrome, or the Continue button in Internet Explorer to execute the rest of the program normally, or until another breakpoint is encountered. Here's an example of breakpoints being set in Internet Explorer at the top, Firefox in the middle, and Chrome at the bottom. Regardless of which browser we're using, the execution of this source code file is stopped at line 63 because of the breakpoint. We'll also be clearing our breakpoints in one of our tutorials. To clear a breakpoint, either click the line number to remove a single breakpoint, or to clear all the breakpoints, right-click any breakpoint and click Remove All Breakpoints or Delete All, depending on your browser. Breakpoints allow us several options for stepping through our scripts. We can either step into our script, executing an individual line of code, which causes the program to pause until instructed to continue. And when we step into, the debugger will stop at each line within every function. Stepping over allows us to skip over function calls. The program still executes, but the function is stepped over. Stepping out executes all remaining code in the current function, and then causes the debugger to stop at the next statement in the calling function. It's possible to trace the values of our variables and our expressions in a watch list. A watch list monitors variables and expressions in break mode. To access the watch list, in Internet Explorer, the watch list is displayed by default on the right side of the pane, and in break mode, local and global variables are displayed. In Firefox, to access the watch list, click Expand Panes, and that'll show the watch list and variables list on the right side of the pane. In Chrome, the watch list is displayed by default on the right side of the pane. To add an expression to the watch list, meaning to monitor the value of any variable, locate an instance of that expression in the program. Select it and copy it to the clipboard, and click to add in Internet Explorer or add watch expression in Firefox or Chrome. Then paste the expression from the clipboard and press Enter. The call stack is an ordered list of procedures, functions, methods, or event handlers that have been called but haven't yet finished executing. Each time a program calls a procedure, that procedure is added to the top of the call stack. Examining the call stack can also be a useful resource in debugging. In Internet Explorer and Chrome, the call stack list is displayed to the right of the code. In Firefox, the call stack list is displayed above the code. Bulletproofing refers to writing code that anticipates and handles any potential problem. One bulletproofing technique is form validation, meaning to validate submitted form data. Exception handling allows programs to respond to any errors gracefully as they occur in the execution of the program. And an exception just refers to any error in a program. When an exception occurs, we can say that the exception is thrown. And when we respond to the exception, we can say that it's caught. We execute code containing an exception in a try statement. The throw statement is part of the try statement and specifies an error message in case an error that occurs within a try block is thrown. Here we can see in our try block that we first try to assign the value of the variable last name to whatever the value of the lname element in our HTML document is. But what if the user didn't enter anything in the lname element? Well, if that's the case, then we would want to respond to that exception using this if statement. If last name is strictly equal to the empty string, meaning no last name was entered, then we'll need to throw this exception, please enter your last name. Then, to catch the exception, we would need to use a catch statement. The catch statement handles or catches, responds gracefully to, the error. The syntax of a catch statement is catch and then the argument in parentheses of the error, and in the block of the catch statement, the statements we want to use to respond to the error. Here's an example. Here we're catching a last name error, and in response to any last name error, we want to display in a window alert the last name error text message, and we want to return the value of false. The finally statement is often included with the try-catch block and executes regardless of whether its associated try block throws an exception. This is used to perform some type of cleanup, or any necessary tasks after the code is evaluated with the try statement. Before we conclude, let's summarize. There are three types of program errors: syntax errors, runtime errors, and logic errors. Error messages are the first line of defense in locating bugs, and browser debugging tools are a useful resource as a second line of defense. A breakpoint is a statement in the code at which program execution enters break mode or temporarily pauses. A watch list is a list of user-specified expressions whose values are displayed and updated in the debugger window throughout the execution of the program. Finally, the call stack is a list of procedures that have started but not yet finished. Bulletproofing refers to writing code that anticipates any potential problems and handles them. And exception handling uses our try, throw, catch, and finally statements to respond gracefully to any exceptions that are thrown.